So this is lesson 7, 9.4, day 1, sampling. You can find it in your B book in the text on page 212. This is not in your notes, however, the next part will be in your notes, so just read along with me and we'll go over this. A sample needs to be representative of a population. Well, a population is the group about which you want to study. The people or could be animals, whatever it is that you want to gather information about. It could be cookies, could be your population. So the group that you want to study, that's the population. If you want to keep track of the speeds of 100 cars on a freeway and then use observations to make conclusions about those cars on the freeway, you will need to know that the cars in your sample are representative of the cars, of all cars that could possibly be on the freeway. So the population could be cars on the freeway. The sample can be the ones that you choose. To make sure your sample is representative, you can choose a random sample. That's always your best choice, is to have a random sample. Random, key word there. A random sample is sometimes called an unbiased sample. A random sample always has these two characteristics. Every member of the population, the group that you want to study, has an equal chance of being selected. So, any person in New York State that tries the lottery has a chance of getting their ticket to win. That's the population. People going in and buying a lottery ticket. It's random. Any person could win. And the selection of the members is independent of each other. Just because you choose Tommy for something doesn't mean that that also means that you have to choose his best friend Billy, for instance. So selections of members is independent of each other. They don't come in 2s or 3s or 4s. So a random sample has to have those two characteristics. You cannot predict which members of a population will be chosen for a random sample because members are selected randomly. A sample which members are not randomly selected is sometimes called a biased sample. So now your notes start, and I know the copy on here isn't very good, but you have it in front of you. Biased and unbiased samples. So to get valid results, a sample must be chosen very carefully. An unbiased sample is selected so that it accurately represents the entire populations. Here's 2 ways that you could pick an unbiased sample. Using simple random sampling, where each item or person in the population is likely to be chosen as any other, so that was one of the requirements, and each student's name is written, for example, each student's name is written on a piece of paper, the names are placed in a bowl, and then the names are picked without looking. Every person had a chance because everybody's name was in the bowl, but you randomly pick out 3 names for the prizes or whatever. Systematic random sampling here says the items or people are selected according to a specific time or item interval. Like every 20th person is chosen from an alphabetical list of all students who attend Martha Brown. You're going to pick every 20th one. Well, everybody still has a chance of being chosen because all students are Martha Brown are in the list, and you're picking very randomly every 20th person. That's a systematic random sample. In a biased sample, one or more parts of the population are favored over the other. So not everybody has an equal chance. 2 ways to pick a biased sample are listed below. So for instance, a convenience sample. A convenience sample consists of members of a population that are easily accessible. Like you want to know 7th graders that like pizza for lunch, and you only ask the people who are sitting at your table. Well, that's not very, that's very convenient that you're asking the 8 or 10 people sitting at your lunch table. That's not random enough. Or another example, it says to represent all the students attending the school, the principal surveys students in one math class. so he only goes to one math class and asks them, what's your favorite lunch? Well, that's really not, because it's in a math class, and it's only one class. Maybe if he picked a few classes, that would make it more random, but that's a biased sample. Another kind of biased sample is a voluntary response sample. A voluntary response sample involves only those who want to participate. So you send out a survey. You are only getting the results from the people who answer the survey. You really want it to be as random as possible and make everybody take the survey, but only certain people will answer it. So students at a school who wish to express their opinions are the only ones that complete the online survey. They want their opinions to be heard. People who don't care about whatever it is you're surveying about aren't going to answer it. So voluntary response sample usually creates a biased sample. So determine whether the conclusion is valid. The conclusion is going to be valid if you have a random sample, because then it's going to be non-biased or unbiased. Justify your answer. A random sample, oh, that's good, a random sample of students at a middle school shows that 10 students prefer listening to rock, 15 students prefer listening to hip hop, and 25 students prefer no music at all while they exercise. It can be concluded, so is this conclusion valid, that half the students prefer no music while they exercise. Well, 10 was rock and 15 was hip hop, so that's 25. So 25 had music and 25 had no music. So 25 out of the 50 had music, which means 25 out of the 50 preferred no music. So it can be concluded that half, 25 out of 50, prefer no music while they exercise. Is this conclusion valid? Yes, it's valid, because it was half, 50%, 25 out of 50, and it's a random sample. Number 2, every 10th person who walks into a department store is surveyed to determine his or her music preference. Out of 150 customers, 70 stated that they prefer rock music. The manager concludes that about half, doesn't say exactly half, doesn't say half of the customers prefer rock music, it says about half. So every 10th person, that's a systematic random sample. Okay, so it's a systematic random sample. So that's a good thing, because you want it to be random. Systematic, I guess I forgot the last part of matic, systematic. Random sample was chosen, and about half, well, 70 out of 150, 7/15, and it's about 46 2/3%. I think, if I did that correctly. 46 2/3%, so that's about half. Is that a valid conclusion? Yes. This is a valid conclusion, because it's a systematic random sample, and that is about a half. It's about half, 50% would be half, so it says about half. Key word there, about. So that is a valid conclusion. That manager is making a good conclusion there, based on a systematic random sample. Random, key word there. Number 3, the customers of a music store are surveyed to determine their favorite leisure time activity. The results are shown in the graph. The store manager concludes that most people prefer to listen to music in their leisure time. Oh, lots of things about stores. So, listening to music is 85%. 9% are other. Playing sports is 6%. So customers in a music store are surveyed. Well, that's a convenience sample. People in the music store are more likely to listen to music. So this is what's called a convenience sample. This is not a valid conclusion because it's not random. It's a convenience sample. It's not random. So it's not valid. It's a convenience sample. It's not random. Even though 85% prefer it, it's more than likely, if you're in a music store, you like listening to music. So that's a non-valid or a biased survey. Number 4, a store sells 3 types of pants: jeans, capris, and cargos. The store workers survey 50 customers at random, key word there, about their favorite type of pants. The survey responses are indicated at the right. If 450 pairs of pants are ordered, how many of them should be jeans? Well, let's see. I have 25, 15, and 20, so that's a total of 50. So how many of them should be jeans? Okay, well, if 25 out of 50 were in the survey, this is a valid survey because it's random. So I can use this results to make a prediction about a larger amount. This was 50 people. Well, if I asked 450 people, what would I expect that amount to be? So I could set up a proportion, and I see that equal ratio wise, I could multiply 9 times 50 to get 450, so 25 times 9 would give me 225. Or I also see that 25 is half of 50, so take half of 450, and they would both be in the fraction of 1/2, and it would be 225. So you could do it equal ratio way, you could set up a proportion, you can see that 50 times 9 equals 450. So 3 ways you could get to this number being 225. 225 pairs of jeans should be ordered based on the survey because it is a valid survey. So 225 pairs of jeans would be surveyed, would be ordered, I would say. Do this problem to, do you understand this? Got it? A radio station asks its listeners to indicate their preference for one of 2 candidates in the upcoming election. 72% of the listeners who responded preferred candidate A. So the radio station announced that candidate A would probably win the election. Is this conclusion valid? Justify your answer. Well, I would say no, it's not valid. Why? Because it doesn't say anywhere in here that it was a random asking of their listeners. People who listen to a certain radio station usually have certain views or could have similar political views, so it does not say random. Listeners were chosen at random. Does not say listeners were chosen at random. I don't know how they were surveyed. And people listening to a similar station may have, similar political views. I don't know, but they could. the most important thing is that it doesn't say that they were randomly chosen. Just because they listen to one radio station doesn't mean that it's everybody in the population that listens in that viewing area. Did every person have a chance? What if you weren't listening that day? Did the entire population have a chance of answering this specific survey? I know 72% sounds kind of high, but it doesn't say that they were randomly chosen, and I'm not sure everyone in the listening area had a chance to answer this. So because it's not random, I would say no, that's not a valid conclusion. I would like you to answer Zach and the Alaskan families question here. These two questions, best on your own, try to give it your best shot. Is it a random sample or is it a valid conclusion? And yes, could you set up a proportion and figure out how many people are expected to vote for Rolling Meadows in this question number 1. Follow the other examples in your notes, and we will go over these tomorrow.